Hello, this is the research team from Gangwon Science High School, and today we would like to talk about our global R&D project, which is predicting the temperature and the seasonal property changes with ML-based climate prediction models. Here are the contents, and first we'll be going through our introduction. So our motivation for the research is we wanted to build a method to accurately predict global warming using a global scale climate model and CFD simulation. The point is, the global scale climate model is machine learning based, so we had the significantly less computing power while staying physically consistent using CFD simulations. And the importance of our research is using high resolution climate simulation at a relatively small scale and seeing the effects globally and much more compute efficiently will help build a foundation of predictions in global warming, especially for smaller research institutes and individuals with significantly less computing power. And here's the background info of how we did our research. So we basically have three things: the low resolution field and the high resolution field and the CFD simulation. The low resolution field is run by a model called ACE2, developed by Allen AI. It's a global climate prediction model with a horizontal resolution of 1 degrees and more compute efficient than the physics-based climate prediction models. And as for the HR field, this is the one we've worked on. We used a high resolution region of interest integrator to calculate the climate at a horizontal resolution of 0.25 degrees, only in the region we want to stay as compute efficient as possible. And we also worked on the CFD simulations to make a physics based simulation, which was run separately to ensure that we could stay grounded down to the predictions with physical consistency. And here are the definitions that you would like I to go through before, getting our research progress. Upsampling, high resolution upsampling, and hyperparameter ablation, and the information is on the right side of the presentation. We would also like you to see the automatic mixed precision (AMP) and also the two-way coupling, which is the fundamentals of our research. Basically, our HR field and the LR field is run at the different layers, so we wanted to couple them together and make their boundaries remain consistent even during long-term simulations. And as for the CFD simulations, here is the definition, and we use these following evaluation metrics and physical consistency. And now let's move on to our research process. First, we set a research goals and pre-process the data. And originally, we had the initial design of the super resolution and based pipeline, which is used to upscale images. But we quickly noticed the limitations as it didn't turn out very great. We'll explain that later. So we defined the ROI HR integrator model using Light UNet and FNO, and we secured the HR and the LR fields using the nudging based two-way coupling, and we optimized and validated the model's performance. Also, we had set a checkpoints and training to ensure that the data was backed up properly. And here is the importance: the super resolution to dynamic prediction. As super resolution cannot achieve physical consistency between time steps, we had to move on to the dynamic prediction. And the nudging and two-way coupling is very important because we wanted on the HR fields and the LR fields to work consistently and make the predictions as grounded as possible. And as for the CFD, we had set up the environment, generated the grid, executed the simulations, and we used the analysis to the HR cell editing process for our further experiment. So for our results, we used the ACE2 model to build upon and constructed the foundational pipeline of the ROI HR integrator and grounded down to predictions with CFD simulation. Here are our results from the CFD and the AI. We leveraged CFD simulations to effectively maintain physical consistency and validate limited local CO2 diffusion within the ROI, confirming stable mole fractions alongside a realistic global CO2 increase. And as for the AI, we developed an ROI HR integrator to enhance high resolution dynamics within the region of interest while maintaining physical consistency, leveraging ACE2's stable long term autoregressive performance. This was our research, and thank you for listening, and I hope you have a nice day. Thank you.